Good morning everyone. So today we will be discussing geometrical optics chapter, and in the last class we discussed magnetism completely, like moving charges and magnetism, also magnetic properties of matter. So today we will start with geometrical optics. Okay, so this is basically just ray optics, and we will revise the chapter first a little bit, then we will go into the PYQs. Now first we have to start with laws of reflection. Okay, you already knew, you are studying laws of reflection from class 10th I guess. So in laws of reflection what they are saying, like the angle of incidence and angle of reflection are equal. What is angle of incidence? Angle between incident ray and normal. Angle of reflection, angle between normal and reflected ray. So these two angles are equal. Then all three, incident ray, reflected ray, normal, all three lie in the same plane. Okay, so this is what our law of reflection states, and there is no further explanation in this, so we can move to the next one. Next is, like, based on the law of reflection, like incident angle and reflected angle will be same, right? So what if initially the mirror was like this, we rotated the mirror with theta angle, what will happen to the reflected ray? So as you can see here, mirror has been rotated by theta angle, so our reflected ray will change by 2 theta angle. We don't need the proof of that, you just study it like this. Okay, when mirror is rotated theta angle, reflected ray will change by 2 theta angle. Okay, I guess it's like everybody understood this. Can we move on to the next topic? What I was saying is, if did not understand, okay, see this, originally the mirror was like this, so incident ray, reflected ray, it was there. Now incident ray is kept the same, I am rotating the mirror, so incident angle will change, right? So incident angle changes by how much? So reflected ray will change by theta, 2 theta angle. If mirror is rotated by theta angle, reflected ray initially it was here, it shifted to this place, so shifted by 2 theta angle. Now is it clear? Anishka, did you understand it? Okay. Next is, like, we don't need the basic principles, we will need extra things like velocity of the image with respect to object. As you can see, in mirrors what is the speciality? Object distance will be equal to image distance. Okay, u equal to v. This is the property of plane mirrors. If an object is moving towards the mirror, image will also move towards the mirror, right, with the same speed but in opposite direction. So if you are taking velocity, let's not think about v and u, let's take that object velocity is VO, okay, and it is equal to Vx I cap plus Vy j cap. This is object velocity. So this is the object, it is VO, in x direction it is Vx I cap, and in y direction it is Vy j cap. So this is Vy and this is Vx. How the image will behave? Image, since it is moving in this direction, image will move in that direction. Okay, but what about the components? Now image velocity we can take as Vi. Okay, in that case this is the x component, this we can say Vxi, and this is the y component, we can say Vyi. As you can see, Vxi is opposite of Vx, but it will move with same speed, right? We can say Vxi equal to Vx or minus Vx. Velocity of the image in x direction is equal to the like speed of x but in opposite direction. Okay, is it clear? Like velocity of the image, it will move opposite to the x direction if like object is moving in towards x direction. Okay, but its speed will be same. If you are taking the y direction, since you can see direction will be same in y direction, so we can say Vyi is equal to Vy. No change in direction also. Here change in direction, therefore minus sign. Is it clear? Okay. So this is about velocity. Now sometimes you like mirror is also moving, then we can simply say relative velocity of image with respect to mirror is equal to relative velocity of object with respect to mirror. Okay, so this is Vi minus Vm is equal to Vo minus Vm, where Vm is velocity of mirror with respect to ground. Okay, if mirror is also moving, relative velocity of image with respect to mirror and relative velocity of object with respect to mirror will be equal. Okay, not like completely, like with respect to ground it won't be equal. Is it clear? So we are learning two things. One is velocity of image in horizontal direction, velocity of image in perpendicular direction. Then if the mirror is moving, how we can relate the velocities. If done, we can move to the next topic. Next is image formed by two mirrors kept at an angle. Imagine that two mirrors are kept like this. Then how much images can be formed by this? This you have seen when you go to this dressing like dress shops and all. When you go into trial room, you can see three mirrors will be kept at like perpendicular to each other. Okay, there how many images of yourself you can see? Now only take two mirrors, so you can see if they are kept at 90 degree, you can see three images. Okay, like that. Voice is breaking. Okay. Is it better now? Okay, so when you go to trial room and all, you have seen mirrors kept like inside, right? So how many multiple images you can see there? If two mirrors are kept at 90 degree and you are standing, you can see your three images inside it. So similarly, that is for 90 degree. What if it is randomly kept at 60 degree? How many images will be formed? So for finding that, we have a formula. Okay, that is if 360 by theta, like let's say our like mirrors are kept at 60 degrees. Okay, then 360 by theta by theta, that is 60 degree, will be equal to what? Odd number or even number? Okay, this will be equal to 6, right? Now see, if is equal to even number, number of images will be 360 by theta minus 1. So in this case, number of image will be equal to 6 minus 1, which is equal to 5. Similarly, with the 90 degree, I took an example. Now same thing you can see, 360 by 90 equal to 4, which implies number of images will be equal to 4 minus 1 equal to 3. Okay, this is the case if this is an even number. Now 360 by theta is equal to odd number, then what? Number of images same as 360 by theta minus 1. Now this is the case where object is placed on the bisector, which means this is the mirror. Okay, two mirrors, and angle between them is 60 degree. There is angle bisector, right? Object is placed on the bisector in that line. Next case, if the object is not placed on the angle bisector and 360 by theta is equal to odd number, like if you are taking some other value, like what you can take, okay, some value of theta where when you divide you are getting an odd number. In that case, number of images will be that value itself. We don't have to subtract 1. If it is not equal to an integer, there are 4 cases. One is object kept on the angle bisector and 360 by theta even number, 360 by theta odd number. Both case we will use this. And object kept not on the angle bisector, even number it will be same, odd number it will be this value. Next one, 360 by theta is not equal to an integer, which means 360 by 70. It won't be an integer value, it will be real number. Then we can't use any of these. We have to count the images separately. Okay, how means, how we will do is, like this is the mirrors. Let's say here is the object, okay, and object is creating alpha angle with mirror 1 and beta angle with mirror 2. Okay, in that case how we will do is, first image will be formed at alpha angle inside the mirror, right? This will be image 1. Then you move beta angle inside mirror 2. So this will be image 2. Then this is direct images. Now this image 1, image 2 will have an image on this side. So that angle is equal to what? From here alpha plus 2 beta. So you take alpha plus 2 beta this side and you will get image 3. Next one, this image 1 will have an image on this side. So that is equal to beta plus 2 alpha. So beta plus 2 alpha, you will get image 4. Like that you can go up to 360 degree, okay, and number of image we can count if 360 by theta is not an integer. I hope I am clear in that. Anyone have any doubt in this? Okay, then let's move on. Next is image formed by spherical mirrors. I don't think you need any explanation in here. So different points we are keeping the object and we are finding where the image is coming, and for finding that we will use mainly we will take paraxial rays, we will not take marginal rays. Paraxial rays means which is near to the axis, rays which are near to the axis. Like a parallel ray coming will reflect and go back through focus, and any ray passing through pole will be reflecting with same angle. So like that, between F and this center pole at F, then between C and F, on C, then beyond C, from infinity. These are the points which we will take, okay, for image formation. I hope that's clear. Moving on, mirror formula is 1 by u plus 1 by v equal to 1 by f, and in case of spherical mirrors, radius of curvature is equal to 2f. Okay, this you have to keep in mind only in case of spherical mirrors. then u image distance, v object distance, f focal length. Magnification in mirror is equal to minus v by u. Okay, these all are like basic things. I know you don't need explanation in that. Next one is called as longitudinal magnification. What we seen in the previous slide, that m equal to minus v by u, that is lateral magnification. Lateral means size of the object, height, how much height difference will be there. Lateral magnification means, let's say we are not keeping a like a point pen type object, we are keeping a ABC box. In that case, how the image will be formed? So you can see its image will be in a distorted way and kind of magnified, right? For finding this magnification, we will take V2 minus V1. V2 means this distance, okay? This distance is V1, this distance is V2. So V2 minus V1, image of first side and image of second side, U2 by U2 minus U1. This is U1 and this is U2. Okay, so based on this we will get lateral magnification. I hope that's clear. Now if you want to find power of mirror in diopters, it is 1 by f, and f should be in meters. You have to convert focal length into meters, then only you can find power of a lens in diopter. Okay, moving on. Next is velocity of the image for spherical mirrors. For plane mirror we already discussed how it will be. For spherical mirrors, what will be velocity? As we already know, magnification for spherical mirror is minus v by u. So height of image by height of object. Height of image equal to minus v by u h. So if the object is moving in perpendicular direction, what will be velocity? We just have to differentiate on both sides. We will get dh by dt equal to minus v by u dh by dt. Okay, so this is vertical velocity, perpendicular velocity of the object, image, it will be equal to minus v by u magnification into dh by, okay, this vertical velocity of image is equal to minus v by u vertical velocity of object. This is the relation. If the object is moving, like this is the principal axis, object moving in this direction, vertical direction. Next is object moving along principal axis. So this is the principal axis, object is moving along the principal axis. In that case, this equation we are getting by differentiating mirror formula. Mirror formula is 1 by v plus 1 by u equal to 1 by f. Both sides we are differentiating with the d by dt. Okay. Then what we will get? Focal length. Focal length is a constant value for a lens. So if you differentiate it, this side will be 0. Then after differentiating on this side, we will bring it to RHS and LHS. Then we will get this formula. This is velocity of image equal to v square by u square velocity of object. Okay, that is velocity of object moving along the principal axis. Next one extra formula you can see here, that is x1 x2 is equal to f square. Okay, what is this formula? Like let's say this is the mirror, spherical mirror. At this point is focal length f. Here is the object O, and let's say here is image I. We know distance from object to mirror is u. This distance is v. x1 is distance from object to focal length, and distance from image to focal length is x2. So if only distance of object and image with respect to focus is given, you can find focus is equal to f square equal to x1 into x2. Okay, this is Newton's formula for spherical mirrors. Is there any doubt in any of the things we discussed now? Okay, then let's move on to the next topic. Next is laws of refraction. In this, first one is like incident ray, refracted ray and normal all lie in the same plane. Second law is Snell's law. And what does it say? Like this is medium 1, this is medium 2. It is having refractive index n1, this is having refractive index n2, and this is angle of incidence. Theta 1 we can say angle of incidence, theta 2 is angle of refraction r. Then what the Snell's law says is that refractive index of medium 1 into sine of incident angle is equal to refractive index of medium 2 into sine of refracted angle, or in simplified way then we are saying sine I by sine r equal to n2 by n1. Okay, in most cases, like if the first medium is air, if first medium is air, then we will say that like refractive index of air is 1. That's why we will simply get it as, write it as mu. But don't study that. Study this form only. Okay. This will help you more in calculations than directly studying sin I by sin r equal to m. Don't study that. Okay. I hope we can move on to the next topic. Next one is refraction through parallel slab. Like a parallel slab is kept, glass slab, and or any transparent slab, through that refraction is happening. So refraction will happen at two phases, right? One first phase is here, second phase is here, and when it happens, it is seen that initial path of ray is this, but after two refractions it is moving through this path, but it is parallel to the initial path. So a perpendicular shift has been happened, that distance is d. If you want to calculate the shift d, it is equal to t sin I minus r divided by cos r. We don't need the derivation again. You can directly learn this formula. T is thickness of the slab, which means this distance is t, thickness, and sin I, this is angle I, this is r. If you know I and r, you can find sin I minus r divided by cos r into thickness is equal to shift in the ray, path of ray. Is there any doubt? Okay. Moving on. Next is called as apparent depth and shift of submerged object. As you can see, when you look into a water tank and all, you can see like when you look from the above and when you look from the side, the image will look different, right? How you see that object. Or when you look inside a water tank, there is a coin, let's say, you will feel like it is closer to the surface than the actual depth. So that is called as apparent depth. And how to calculate that? Actually the object is here, but when you look from here, the object will be look as if it is here. Okay, so what I was saying is that like there are two objects. Like when we are observing from a rarer medium and object is inside a denser medium, its actual depth will be shifted up. Now if you are looking from a denser medium and object is in rarer medium, its depth will be increased. Okay, so how we can find that? Apparent shift. So this is the distance which we will be seeing, d dash, and this is the actual depth d. Then you can say that apparent shift d dash is equal to actual depth into 1 minus n relative. N relative means relative refractive index. Okay, so that's how you find d dash. Is that clear? Okay, here n relative will be, if this is n1 and this is n2, it will be n2 by n1, n relative. Okay, then we can move to the next topic. Next is total internal reflection. Okay, total internal reflection, what does it say? It is only applicable if incident ray is in denser medium. Okay, light is traveling from denser to rarer medium only, total internal reflection applies there. So this is water, a denser medium, it is having n1 refractive index. This is like a next medium, that is n2, rarer medium, n2 refractive index. So what does it say is that when light goes from denser to rarer medium, what happens? The refracted ray moves away from the normal. Like that, after moving away so much, at some point the ray will pass parallel to the surface, like interface is there, no? It will pass parallel to that. That incident angle is called as critical angle. Okay, in that case, if you see our formula, this is n1, no? So n1 sin theta c, critical angle, is equal to n2 sin 90. n2 is rarer medium. If you get confused, instead of n1 and 2, you can write nd nr. Okay, for not getting confused. Rarer medium, and because incident angle is in denser, other is rarer medium. Then you can see that sin 90 is 1, which means sine of critical angle is equal to n rarer divided by n denser. In case if a rarer medium is air, so it will be 1. Then we can say, if rarer medium is air, we can say sin theta c is equal to 1 by n. That will be just of denser medium. Okay, if second medium is air. Is there any doubt in this total internal reflection? Okay, then we can move to the next one. Next is refraction through prism. Okay, prism formulas we need to learn. As you can see here, there are mainly two formulas. First formula is refractive index of the material. If you want to find that, you need angle of prism A, D is angle of minimum deviation. If you know these two values, you can find mu. But maybe you won't be getting problems with that one. Okay, rather than for that, you will need to use this formula. Okay, delta is deviation. Okay, not minimum deviation. Delta is at any angle what will be the deviation. Okay, instead of writing I1 I2, I will write in different way. So deviation for any incident angle is equal to I incident angle plus E emergent angle minus A. How this formula is coming? A is equal to R1 plus R2. R1 and R2 are refracted angle at surface 1 and 2. So if you are seeing here, this is R1, okay, and this is R2. This angle is delta deviation. This I2 I am writing as E emergent angle, and here is I. Angle of prism is here. This is angle A. So what are we getting? R1 plus R2 equal to angle A. Deviation is equal to I plus E minus A. You will get majority of questions for solving using this one or critical angle. Okay, most of the question will be based on these two formulas or based on critical angle. So like keep that in mind. Can we move on? Another thing is dispersive power of prism. Dispersive power means when white light enters the prism, it will be split into different components. Why? Because refractive index. What is refractive index? Refractive index of a medium is equal to speed of light divided by velocity of light in that medium. Okay, refractive index of a medium is equal to speed of light divided by speed of light in that medium. So velocity of light, how can we write? Frequency into lambda. Okay, so frequency won't change when medium is changed. Wavelength will change. That's why velocity is changing, right? So C equal to nu naught lambda naught, frequency and wavelength in vacuum. Frequency will not change in medium, so it will be nu naught, but lambda will change. Therefore, we can say refractive index is also equal to lambda in vacuum divided by lambda in medium. Understood? So, when wavelength changes, refractive index should change, because for violet light wavelength is different, wavelength ratio will be different. For red light wavelength ratio will be different. Similarly, for each light, each particular radiation, depending on wavelength, refractive index will be different. So, we can say that NV, okay, NV is for violet light. For violet light, what is refractive index? NR is for red light, okay, refractive index for red light. NY is for yellow, NY for yellow. If you know refractive index for this, you can find dispersive power. Now, let's say NV and NR is only given, NY is not given, then you can find NY is equal to NV plus NR divided by 2. Okay, is that clear? This is for finding dispersive power of prism. If no doubts means we can move on to the next topic. Okay, next one, refraction at spherical surface. In this you might have learned these two formulas, okay, lens maker's formula, lens formula and magnification of lens. But one more you need, because sometimes problems will be coming based on that. That is only one spherical surface. You have seen for the derivation of lens maker's formula, okay. So, there is only one spherical surface and this is that medium only. So, if object is placed here, how we can find these things? So, here this is N1, this is N2. Radius of curvature of this spherical surface is R. Then we will get image N2 by V minus N1 by U equal to N2 minus N1 by R. This formula we are using for two surface and deriving lens maker's formula, okay. But this is just for one spherical surface, this you will need. Next is lens maker's formula. Based on this you can find if the lens is converging or diverging lens, because 1 by V minus 1 by U, that is equal to 1 by F equal to N relative minus 1 into 1 by R1 minus 1 by R2. Here N relative is nothing but N2 by N1, okay, this is N relative. Now you can see for converging lens, okay, converging lens F should be positive and diverging lens F should be negative, okay, which means this there are two quantities, both are positive, F will be positive, both are negative, F will be positive. So, if this is negative, it will be a converging lens. This is positive, it will be a converging lens. In case this is negative, this is positive, it will be diverging lens. This is positive, this is negative, it will be diverging lens. So, based on sign of these terms, we can find if it is converging or diverging. For this side to be negative, it should be, you know, like a convex lens. Convex lens means this side will be negative. Concave lens, this side will be negative. Convex lens, this side will be positive. Here, if lens is having denser medium than the surrounding, this will be positive. Lens is having rarer medium than the surrounding, this will be negative value. So, based on that, you should be able to say is it converging or diverging lens. Is that clear? Is it clear for all? Okay, I hope you understood, so we can move on. Next is combination of lenses. Combination of lenses, like if number of lenses are kept close together, like 3 lenses are there, then effective focal length will be 1 by f1 plus 1 by f2 plus 1 by f3. This we are getting from effective power equal to p1 plus p2 plus p3. Like this, from this we are getting effective focal length formula. Similarly, if 2 lenses are kept at d distance apart, then this formula we have to use. D is the distance between them, 1 by f1 plus 1 by f2 minus d by f1 f2. Okay. Next one, combination of lens and mirror. If a lens and mirror is kept, spherical lens, spherical mirror is there, then we have to use this formula. 1 by f equal to 1 by focal length of mirror minus 2 by focal length of lens. Why? Because let's say this is our like lens and this side is mirror. Okay, what happens when a ray comes? First it will refract, then it will reflect, then it will again refract. So 2 times it is passing through the lens. That's why it is 2 by FL. Okay, is it clear? This is first time reflection, then second refraction. 2 refractions are happening. If that's clear, we can move on. Okay. Next is simple microscope, compound microscope and astronomical telescope. These are optical instruments. We need to know magnification for this. Okay, for simple microscope, for everything there are 2 cases. First case, normal adjustment means image is formed at infinity. See, this is normal adjustment. Okay. Normal adjustment, image is formed at infinity. Then there is image formed at point D. Both cases we are using D. If nothing is specified in the question, if they are not saying image formed at infinity or image formed at the near point, you have to assume it is normal adjustment. Okay. If nothing is specified, we have to assume it is normal adjustment and we have to apply the formula. If image is formed at infinity, magnification is equal to d by f. Image is formed at near point, magnification equal to, for simple microscope is just 1 lens. For 1 lens, image formed at near point, m equal to 1 plus d by f. Same thing, compound microscope. But compound microscope, m is equal to magnification of objective into magnification of eyepiece. 2 lenses are there. Same way, if multiple lenses are there, magnification we will multiply together to get final magnification. As you can see, it is formed at infinity. For eyepiece, image formed at infinity, we will use direct this formula, d by fe. And for objective, it will be minus L by FO. L is length of the tube. L, length of tube. Okay. Next, image formed at near point eyepiece formula is this, and like objective formula is no change, minus L by FO, and this formula we are keeping it here. Similarly, if it is a telescope also 2 are there, objective and eyepiece. Here also magnification is equal to MO into ME only. But for normal adjustment, it is just FO by FE. And image formed at near point, it is equal to FO by FE into 1 plus FE by D. Okay. I hope you understood this, and we can move on to the PYQs. Is there any doubt? Okay. Going to the PYQs, first question. It is from 2025. A microscope has an objective focal length FO equal to 2 centimeter. Eyepiece focal length FE equal to 4 centimeter. And the length of the tube is 40 centimeter. And distance of distinct vision near point is equal to 25 centimeter. Magnification in the microscope. So they haven't mentioned it is like normal adjustment or anything. So we have to assume that it is normal adjustment. In normal adjustment, what is the formula? Magnification is equal to minus L by FO and into D by FE. Okay. In the options they haven't mentioned the negative sign, so we need the only magnitude. Okay, just substitute the values. You will get 40 into 25 divided by 2 into 4, 10, 250 by 2, 125. Okay, magnification will be equal to 125. Answer option D. Everybody understood this? I hope it is clear. We can move to the next question. Next one, in a certain camera, a combination of 4 similar thin convex lens. 4 lenses are used, arranged in axially in contact, like in same axis 1, 2, 3, 4 like that. The power of combination and total magnification of the in comparison to power P and magnification M for each lens. So each lens is having power P and magnification M. When they are kept like in combination, what will be the final power and final magnification? As I told you, power will increase as P1 plus, P2 plus, P3 plus, P4. Now each are having same P power, so it will be equal to 4P. Out of the option, there are 2 options saying 4P. Okay, now let's see magnification. Magnification will be M1 into M2 into M3 into M4, and since all of them have same magnification M, we can say this will be equal to M to the power 4. Okay, so answer is option A. Is that clear for all? I hope so. Let's move on to next question then. Next one is, a light ray enters through a right angled prism, which means angle of prism is 90 degree at point P at angle of incidence 30 degree as shown in the figure. It travels through the prism parallel to base BC. So this is parallel to base and emerges along the face AC. So emergent ray is parallel to AC. Refractive index of the prism we have to find. Okay, let's talk here. So this is 90 degree, which means this will be critical angle theta C. Okay, and this angle will be R1. We know that R1 plus theta C is equal to 90 degree. Okay, similarly, what do we know? Sin theta C will be equal to 1 by refractive index. We are assuming that surrounding medium is air. So 1 by refractive index of the prism will be sin theta C. Then what do we know? If you take 30 degree and R1, sin 30 divided by sin R1, this will also be equal to mu. Okay, so we know this many details, substitute it and we can find the answer. Can you do by yourself? Okay, if you want, I will give you some clue. R1 we can write as 90 minus theta C. So this will become sin 30 divided by sin of 90 minus theta c. 90 minus theta c will be cos theta c, and sin 30 equal to 1 by 2. So mu is equal to 1 by 2 cos theta c. That you will get. From this one, if you substitute it, sin theta c is equal to 2 cos theta c, right? Then sin theta c by cos theta c you can substitute equal to 2. So tan inverse 2 will be answer. Okay. Basically you will get answer as root 5 by 2. I think you can solve it. Moving on. Next one. A small telescope has an objective of focal length 140 cm and an eyepiece of focal length 5 cm. Magnifying power of telescope for viewing distant object. As I told you, if we are assuming that like nothing is given, a normal adjustment or other thing, what we have to do, we have to assume it is normal adjustment. In normal adjustment for telescope, what was the formula? M is equal to Fe by Fo, right? Or Fo by Fe? Fo by Fe, okay? So focal length 140 and 5 it is given. So we can directly substitute it. It will be 140 divided by 5. How much you will get? 28, right? 28 will be the answer. I hope you understood this. Since nothing is specified, we will assume that it is normal adjustment. Next one. A lens is made up of 3 different transparent media as shown in figure. A point object O is placed on axis beyond 2f. How many real images will be obtained on the other side? So for this there are 3 media. So 3 region will be refracting the light in 3 different points, right? This region will have some focus, this region will have other focus, this region will have other focus. So 3 different images we will get. That will answer is 3. Okay, it is purely conceptual question. There is no formula to apply in this. Okay, moving on. Next one. Epsilon naught and mu naught are electric permittivity and magnetic permeability of free space. If the corresponding quantities of medium are 2 epsilon naught and 1.5 mu naught respectively, refractive index of the medium will nearly be. So this is what I told you. Refractive index, how we will find? It is equal to C by V. Then we have another formula relating C equal to 1 by root mu naught epsilon naught. So V will be equal to 1 by root mu m epsilon m. Like for that medium, what will be that values? So this will be equal to under root mu m epsilon m divided by mu naught epsilon naught. Mu m epsilon m is given. That is equal to under root 2 into 1.5. That is equal to root 3. Answer is option B. Is it clear? Okay, moving on to the next question. A horizontal ray of light is incident on the angled prism, right angled prism, with prism angle 6 degree. So this angle is just 6 degree. If the refractive index of material of prism is 1.5, then angle of emergence will be. Okay. So it is entering normally. Normally means there will be no refraction at that angle. So directly here it is hitting here. Let's say the angle is R and this is angle of emergence E. Then if you want to find a refractive index E, then how you will find? Okay, sin E by sin R equal to mu. Okay, and mu equal to 1.5. So sin E equal to 1.5 into sin R. We have to find E, right? Now let's see. Since angle of prism is very small, R will also be small. Okay, and R plus like that value we have to calculate it as like R plus the other value should be 6 degree, right? And if you see here, if this is 6 degree, what this angle will be? Total should be 90 plus 6 plus, let's say this is x. X is equal to 180 degree. So x is equal to 180 minus 90 minus 6. 180 minus 90 is 90 degree. 90 minus 6 is equal to 84 degree. Okay, so this angle should be 84 degree. Okay, then 84, 90 minus 84, R should be equal to 6 degree. Since angle is very small, we have to assume that sin theta approximately equal to theta if theta is very small. So this side we can assume E equal to 1.5. E will also be a small value, 1.5 into R. R we got as 6. 6 into 1.5, 3 by 2. We can write it as 9 degree. Answer is option A. Okay. Is there any doubt in this? Here we are taking extra assumptions. Okay, when theta is very small, we have to assume that sin theta approximately equal to theta, and based on that we are finding this answer. Okay, moving on to next topic. Next question. Two identical glass mu g equal to 3 by 2 equiconvex lenses of focal length f is kept in contact. Space between two lenses filled with water mu equal to 4 by 3. Focal length of the combination will be. Okay, so there are two lenses kept in contact. So in this medium is filled with the water. Okay, in between them. Then since it is identical, its R will be same. Okay, first one is having, this is having 3 by 2 mu, this is also 3 by 2. Here it is 4 by 3 mu. Okay, how do we find focal length of each? This is having focal length S, this is having focal length F. How are we getting that? 1 by F equal to mu minus 1 into 1 by R1 minus 1 by R2. Yes? Dhanasri, any doubt? Okay, I hope not. Okay, this is the formula. Since they are identical, R1 equal to R2. Okay, but R1 is in positive side, R2 is in negative side. So this will become 1 by F equal to 3 by 2 minus 1 into 2 by R. This is 1 by F for lens. Now for water, 1 by focal length of water's lens, if you want to find, that should be equal to what? It should be equal to 4 by 3 minus 1 into 2R. Okay, so based on this, 2R you can find as 3 by 2 minus 1, 0.5, 1 by 2. Okay, so which gives us that 2 by R is equal to 2 by f, which means r equal to f. Substitute it here, you will get 4 by 3 is equal to 4 by 3 minus 1 is equal to 1 by 3. 2 by r equal to 2 by f. From this we will get it is equal to 2 by 3f, or focal length of water lens is equal to 3 by 2f we will get. So f1 equal to f, f2 equal to f, focal length of water is equal to 3 by 2f. Based on this, we can find final focal length is equal to 1 by f1 plus 1 by f2 plus 1 by f3. Then you will get the answer. Okay. 1 by f plus 1 by f plus 2 by 3f. If you take f common, you will get 1 by f into 2 plus 2 by 3. Okay. So in that, and this will be minus sign. Okay, sorry. This will be minus. Why? Because it is converging lens. Both sides we have converging lens. In the middle it is diverging lens, so it should be negative value. Okay, so this we will get as 6 minus 2, 4 by 3. 4 by 3, f is 1 by f. So f is equal to 3 by 4f. Answer is option D. Okay. It is lengthy, but like easy concept only. Moving on. Next is match the corresponding entries of column 1 with the column 2. Okay. M is magnification. Now based on m equal to minus 2. M negative sign means it is inverted. Okay. Like above principal axis erect, below principal axis inverted. So minus sign means that it is inverted. Inverted image is produced by what? It will be real image. A will be real image and also created by concave mirror. Convex mirror most of the time it will create what? Erect and like virtual images. Okay. So AQR coming in one option only, so we can directly answer it is option C. Okay, we don't have to further check the other ones also. Directly find QR option C. Okay. Moving on to next topic, next question. Angle of incidence for a ray of light at refracting surface of a prism is 45 degree. Okay, so angle of incidence equal to 45 degree. Angle of prism is 60 degree. A is equal to 60 degree. Ray suffers minimum deviation through prism. Angle of minimum deviation and refractive index of material of prism respectively are. So we have to find minimum deviation and refractive index. Condition for minimum deviation, delta minimum condition is that I equal to E. If I is equal to E, in that case we can say that R1 equal to R2 equal to R. And we have our formula A equal to R1 plus R2. If both are equal to each other, this is equal to 2R, which means R is equal to A by 2. A is given 60 degree, so R equal to 30 degree. Okay, so what we have to find? Minimum, delta minimum and R. Delta minimum, how we can find? Delta minimum is equal to I plus E minus A. A is already given. Since I equal to E, this will be equal to 45 plus 45, 90 degree minus 60 degree, which is equal to 30 degree. as you can see, two options are there, B and D. In that we have to find refractive index. Okay, how to find refractive index? Refractive index will be sin I by sin R1 equal to refractive index. Sin I is sin 45 divided by sin R1 is 30 degree, which is equal to root 2. Okay, answer is option D, 30 degree root 2. Is it clear? Is there any doubt in this? Okay, let's move on to next question. A astronomical telescope has objective and eyepiece of focal length 40 centimeter and 4 centimeter. So, focal length of objective equal to 40 centimeter, focal length of eyepiece equal to 4 centimeter. To view an object 200 centimeter away from objective, so U is given as 200 centimeter. Lenses must be separated by a distance of what? Okay. So we are assuming that this is the objective, okay, and at 40 centimeter is focal length of objective. At 200 centimeter our object is placed. Then what will happen? It is beyond C, right? So if this is eyepiece and we are like trying to see it at 25 centimeter, like at minimum deviation distance, what should be length L? That is the question, sorry. Okay, let's see, like for astronomical telescope, which formulas did we study? Okay, if you are seeing the formulas, we have two formulas. One is at normal adjustment, another is at near point. Okay, so let's say we are finding at a near point, our magnification formula we have, but we don't need that. We need where the object, how much will be the length of the tube. Okay, now for length of the tube we usually take it as FO plus FE during like normal adjustment. If it is not normal adjustment, we cannot find like that. So first we have to find image distance of this. Okay, VO we have to find. How we will find VO? 1 by VO minus 1 by UO, this is UO, is equal to 1 by FO. From this we will find a VO, that is image distance of objective. After that, after finding that, we know VE is equal to D, that let's take it as 25 centimeter. Okay, it will be virtual image, so it will be minus 25 centimeter. Then we can find UE, 1 by VE minus 1 by UE equal to 1 by FE. We have to find FE by substituting this. Then finally, when you get UE and VO, L is equal to VO plus UE. Okay, this is how we find it. First we will find image distance due to O, like objective. Then we will find object distance for E, like for eyepiece. Both combined we will get what is length of the tube, and when you solve it you will get answer 54 centimeter. I am not substituting all values. Okay, U is given, UO is given equal to minus 200 centimeter, FO is given as 40 centimeter. Okay, already written that. Okay, okay, and FO, FE is also given. then we can easily find this. VE is equal to D equal to minus 25 centimeter. Okay. With these values we will be able to solve. Next one, beam of light consisting of red, green and blue colors is incident. There is a spelling mistake. It's incident on right angle prism. The refractive index of material of prism for the above red, green, blue wavelengths are 1.39, 1.44 and 1.47. Okay. So all of them are incidenting at right angles, means perpendicularly, normally to the surface, and this angle is given as 45 degree. So obviously this angle also 45 degree. Then if we refractive index is given for each prism as 1.39, 1.44 and 1.47 respectively. Okay. And now if you are seeing sin theta c, okay, if this is angle 45, they will all be incident at what angle? 45 degree. Okay. And sin 45 is equal to what? That you will get as 1 by root 2. Okay. Sin 45 equal to 1 by root 2. If you find this is equal to 1 by mu, okay, then mu equal to what? Mu equal to root 2, which is equal to 1.414. So this is the critical angle. If the refractive index is more than this, they will pass, but if refractive angle is less than this, it will not pass. Okay. So you can see for these two, their refractive index is more than that value. So they will not get like deflected. Red, but it is having 1.39, which will have separated. So you can see that separate the red color part from green and blue colors. This will be the answer. Okay. Now moving on to next one. Two identical thin plano convex glass lenses, 1.5 mu, each having radius of curvature 20 centimeter, are placed with their convex surface in contact at the center. So they are kept like this. Okay. The intervening space is filled with oil of, so this region is filled with the oil of refractive index 1.7. Okay. Then focal length of the combination. So this is having 1.5, this is having 1.5, this is having 1.7 refractive index. Focal length of combination. This is the similar one we did before. This is having radius of curvature 20 centimeter. Okay. So let's say this is lens 1, lens 2, lens 3. 1 by f1 is equal to refractive index of 1.5 minus 1 into 1 by r1. r1 is in negative side, so minus 1 by r1 minus 1 by infinity. 1 by infinity will be 0. So r1 is equal to 20 centimeter. This will be 0.5 divided by 20. So f1 we will get as minus 40 centimeter. Similarly, next one we are calculating. This will also be 40 centimeter, but to this direction. Okay, so f2 we will get as 40 centimeter. Next we have to find for middle region. Okay, middle region, if you are finding, it is having two surfaces. Both surfaces are there. 1 by f3 is equal to 1.7 minus 1, then minus 1 by 20 centimeter minus 1 by 20. Okay. So final value will be 0.7 into 2 divided by 20. Okay. this we will get as 7 into 2 divided by 20 into 10. This will be 5. So based on this you can solve for F3 is equal to what? 20 into 5 is 100. Okay. 100 by 7. And a negative sign is there. Sorry. Negative sign will also be there. So minus 100 by 7. F1, F2, F3 we got 1 by F equal to 1 by F1 plus 1 by F2 plus 1 by F3. Substituting these values, you will get what is the final focal length. Answer is option A, 50 centimeter. Okay. Is there any doubt? Okay, moving on. Two plane mirrors are inclined at 70 degrees. A ray of incident on one mirror at angle theta after reflection falls on second mirror and is reflected from there parallel to the first mirror. Value theta is. So, let's say this is two mirrors. Okay. Angle between them is 70 degree. Okay. Another ray, it is falling incident at a theta angle. Okay, this angle is theta. It is reflecting with the theta angle, right? This angle is theta. Then after reflection from this, it is going parallel to this. Okay, so this angle we can say as 70 degree, which means this angle will be 20 degree. This angle is equal to 20 degree. So then from here, okay, this angle 70 degree, this angle will be 180 minus 140. This is equal to 40 degree. This will be 90 minus 40, 50 degree. Okay. Answer is option D. Is there any doubt? I hope not. We will move to next question. This is the last question for today. For a normal eye, cornea of eye provides a converging power of 40D and the least covering power of converging power of eye lens's cornea is 20 degree. Using the information, distance between retina and cornea eye lens can be estimated to be. Okay. So cornea and lens, it is here and this is retina. Okay. So for this combination, cornea power is equal to given as 40D and for this power is given as 20D. Okay, this is power of lens. Now effective power, P effective is equal to 40 plus 20 equal to 60 diopter, which means focal length of effective combination is equal to what? 1 by 60. Okay, from this you will get focal length value, that is our distance between cornea and retina. Okay, answer is equal to 1.67 centimeter. I hope Sanjay was listening, I think. So if it is the case, we can stop the class here. Join back for chemistry class at 12 o'clock.